Okay, good morning. So let us start today's lesson. I thought that we are supposed to teach about quadratic functions, but there is one section which is also important I didn't realize. This is section 3.3. It's called root equations. Yeah, that's also very important. So let us talk about this. And that's actually a natural place to talk about root equations because usually they give rise to quadratic equations. So we should be able to solve these problems. So what do I mean by a root equation? Of course, probably you know it's an equation which includes some kind of root sign, yes? So and then you are supposed to find it. Probably the simplest example that I can mention here for you is square root of x equals to 5. That's a root equation because it's an equation, it contains an unknown, and you are supposed to find that unknown in a way that it solves your problem, yes? Of course, this is very, very simple that you can guess. What is x here in this case? What is that? 25. Is there any other numbers there? No. So that's the only one. So 25 is the only answer to this problem. Okay, now if you want to have a general strategy to solve this problem, what do you think? How should be my general strategy? Because root equations can be complicated. For example, I can have this. I don't know, I'm just giving a random guess here for you. So for example, like this. So might be we are not able to guess. So we should have a general strategy, if possible, to solve the root equations. Yes?
I mean, like try to remove the square, the root sign, or like
Just. Okay. Sorry. Yeah.
I mean, in the first case, I just square both sides. And,
Yeah. So what is the general strategy? Yes, you're right here.
well, trying to remove the root sign.
Exactly. But that is the best way to answer the question. We are supposed to get rid of this square root third signs. Yes. So here I have only given you the second root, but you might also have the third root somewhere here. Of course, immediately you see that these problems could be really complicated if I want to get rid of all these third signs, yes? But you are right. So I need to find a way to get rid of all third signs in the problem and change the problem into a problem without third signs, hoping that I can solve that new equation. But there's also one important difficulty here that you have to be careful about, and that is if I give you this equation, and you want to solve this equation using this strategy, it is really simple. You square both sides because your goal is to get rid of that, and then this to the power of 2 is x, this to the power of 2 is 25. And that's the correct answer that you guessed. Now let us say that I have given you this from the beginning. Okay, what is the answer to x in this case? Yes?
Undefined.
There are no answers for this, yes? Which number you want to put here so that the output of a square root sign becomes negative 25? So there are no answers, yes? So because the output of a square root sign is always a non-negative number. Yes? But if you naively do this strategy to get rid of this third sign, what will happen? This becomes x again, this becomes 25. So you will get 25. Yes? So you see that when I start for this one, I get 25, which is the correct answer. But if I follow the same strategy to solve this one, I get 25 again, which is a wrong answer. This is not the answer for this. The problem is because these things are not equivalent if I have an even root. For example, if I say that if x squared is equal to 4, so let me write it in that way. If x is equal to 2, then x squared is 4. This is guaranteed. But not the other way around. I cannot go back. So this means mathematically this statement and that statement are not equivalent. Okay? And that's exactly the problem. Because at the end, you are not solving this equation. For example, let me give you another example. For example, if I give you a square root of x minus 1 is 7, and I ask you to solve the problem. You raise it to power 2. Yes, it becomes x minus 1 squared is 7 squared. And then this becomes x minus 1 is 49. You see, here you start solving this equation. And the answer becomes 49 plus 1. And the answer becomes 50. If I say that when the solving process has started, you don't point here. You say that from here I solved the problem. So did I solve the original problem? In principle, no. I solved this equation with the hope that the answer that I get for this new equation is also the answer for the previous problem, original problem. Is that clear? So when you raise, unfortunately, you get an equation which is not equivalent to the original equation, but the solutions of the original equation are among the solutions of this new equation. Yes? So when you solve this, the solution here, the set of solution contains more answers with respect to this one. Yes? Is that clear? Okay. So that is why it is important to do this. Whenever you get rid of a square root sign, you get a new equation, you solve that new equation, you are confident that the solutions that you get are possible solutions for the original equation, but then you have to check them in to see if they work or not. And that is a strategy for solving, yes? Because you might say that, okay, at the end I am checking numbers one by one. Yes, you are checking numbers one by one, but how many options are available? Only finitely many. If you want to start checking all the numbers here, there are infinitely many possibilities. You narrow it down to a set of finitely many numbers, and then you check them. That is the strategy, yes? Is that clear? Okay. I want you to understand, if someone asks you why this happens, so for example, let me see here, if I give you the same equation, yes, and I ask you to solve this, you follow the same strategy, so then it becomes x minus 1, this becomes positive 49, and the same, you see, I am not solving this, the solution hasn't started yet, I am getting rid of the third sign. The solution starts from here. And then I move it to the other side, x becomes 50. But before putting it in a box and accepting it, you need to remember there is a danger. It might happen that this is not a root of the original equation. You have to go back and check it. Is this a real solution for this? No, because if I put 50 here, 50 minus 1 is 49, square root of 49 is 7, not minus 7. So then you say that this is a false root. Yes? And then you say that there are no solutions for this problem. I want you to understand, if someone asks you, okay, I am doing mathematically, I am doing everything mathematically sound, why I get a false root, you should be able to answer that. Okay, how do you answer that again? I want to make sure that you understood it. You see, I am doing completely correct things. Yes, you say that if this number is equal to this one, so a square of this number should be equal to a square of this one. And then this squared is this one, definitely true. This to the power of 249, definitely true. I move this to the other side. Everything that I have done is definitely true. And it gives me the correct answer. And I have done everything true again. Every step that I have taken here is also true, but it gives me a wrong answer or a false root. If someone asks you why this is the case, you should be able to answer that. Why this is the case? I actually answered that, but I want to repeat it. Anyone else? Yes?
Well, they're not equivalent.
They are not equivalent. This is the same easy sentence. You see, this statement, if I have this, I can square it. But if I solve this, there is no guarantee the solutions are the solutions of the original equation. What are the solutions of this equation? 2 and minus 2. One of them is the answer, one of them is not the answer. They are not equivalent. So you should expect that when you raise to even powers, this will happen. Then you might have a fake root or a false root. Yes? So that is extremely important, that after solving the problem, you have to check your answers. Okay? And this is, I want you to understand, this is really possible, because in the beginning, I have infinitely many possible numbers to guess. I didn't guess all of them. By this method, I only come to 50, and I have to check one number, 50. If 50 works, that's the solution. If 50 doesn't work, I don't care about any other numbers. It is not possible to have any other number as a solution. Yes, that is so. It's a general strategy. But these problems can be very hard sometimes. But the good point is that you don't need to be worried very hard about very hard equations like this. So even I don't know if I can solve this myself, because this is the third root, it's the second root. I have to get rid of all the third signs. Okay? Okay, so what we learned two things. The general strategy is to get rid of all third signs in the equation. The second thing I have to be careful is that whenever I get an answer, I shouldn't be so happy, because that might be a false root. I have to check that one again against the original equation. These are the only points that you have to keep in mind, yes? Okay. So, for example, let me start with problems in the book first. So they have given you, of course, I start from here. So you are supposed to solve this equation. 4x plus 3 equals to 3x plus 2. But before going further, because I don't know if there are more third signs here, but let me just tell you. If x equals to 2, and I raise it to an odd power, x to the power of 3 becomes 8, definitely true. But do you think in that case I can also go back and conclude that if x to the 3 is 8, x is also 2? In this case, yes. So in this case, mathematically, these two are equivalent. If I solve this one instead of that one, I really don't need to check anything, because they are equivalent. But for the case of even powers, I have to be more careful. Yes? Okay, so that is the problem given in the book. We are supposed to find x. So what I'm supposed to do? I have to get rid of third signs, yes? And then it is very simple. How should I do that? I raise both sides to power 2, yes? This becomes 4x plus 3. I raise it to power 2, and this one the same. Square root of 3x plus 2 squared. And then this becomes 4x plus 3. On the right-hand side, I will have 3x plus 2. You see, if I tell you, have I started solving any equations? You say no. The process of solving hasn't started. The process of eliminating this square root sign has started. Yes? But now, I am solving this equation, which you see, this equation is not exactly that equation. But instead of this equation, I solve that one. How? This is very simple. I move this to the right, to the left, and I move this one to the right. What is happening here? This is x. What is there? It's minus 1. Can I be sure that this is the answer yet? Not yet. I have to go back and check it. Is this an answer or not? Put minus 1 in the original equation. What do you get? You get minus 4 plus 3, which is the square root of minus 1, which is meaningless. So this means that even though I got this, this is not acceptable. It's a false root. Yes? So it's a false root. And then what is the answer to this problem? There are no solutions. Of course, I emphasize real, but you don't need to be worried, because everything we learned in this course is real. So there are no solutions to this equation. Okay? Is that clear? Yes?
I don't get why it's about true.
No, because, so you get rid of the third signs, you get a new equation. Yes? Here, from here to here, am I solving this equation? Your answer should be no, because you see I am solving this new equation. Yes? And I told you that this new equation and the original equation are not equivalent, because the operation of squaring is not reversible. Yes? Because you see that if x is equal to 2, I can conclude that x squared is 4, but not the other way around. Because if x squared is 4, there are two options, either 2 or minus 2. So when I square something, it is correct. But if I want to go back, it is not equivalent. I cannot immediately go back. I have to be careful. Now I am doing the same thing. I am squaring these two. Instead of solving this, which is my task to do, I am supposed to solve this equation, but I raise both sides to power 2 and I get a simpler equation. But this equation, for the same reason that I told you, is not equivalent to this equation. Yes? Okay, for the time being, this is the best I can do. I start solving that and I get an answer. This answer is definitely the answer of this one. You don't need to check anything. But this equation is not equivalent to the equation given to me. This means that the solutions of this equation are among the solutions of this equation, but there is no guarantee that all of them are the answer to the original equation. So you need to check them. Yes? And how I check them? I put this into this to see if it works or not. So I put 4 times, instead of x, I put this answer that I got, plus 3, and I ask myself, is this equal to 3 times minus 1 plus 2? It's a good example in the book, because if you calculate this, what's the answer? Minus 4 plus 3 is the square root of minus 1. And if you calculate this one, what is the answer? Okay? But do you say this is true or false? It seems to be true. Square root of minus 1 is equal to square root of minus 1. But be careful. The square root of minus 1 is not a real number. So it's not a number. I can put equality between two numbers and say if it is true or false. I can say 1 over 2, 2 over 4 are equal numbers. Because this is defined, and I say that the values are the same. Yes? But the square root of minus 1 is not defined at all. It's not a real number. Yes? So this means that if in the future you talk about complex numbers, yes, that would be a solution if I am allowed to work with complex numbers, but not now. Yes? Okay. So this is, anyway, that's a false root. So there are no solutions for this equation. Is that understandable? Yes? Okay. So now let me give you a little bit better example. That's also in the book. Then I will give you a little bit harder ones. So this is also a good question. I want to listen carefully because this is important. So 2x plus 1 plus x is equal to 7. Yes? I have seen students make a lot of mistakes calculating this. Even though the general strategy is to get rid of the third sign here, and we know that somehow I have to raise it to power 2, but it is not a good idea if I start raising to power 2 right now. I want you to understand why, because memorizing is not good, okay? So assume that I am doing the wrong thing. I want you to feel why this is not working. Yes, assume that you raise both sides to power 2 immediately. Then let us see what happens. On the right-hand side, I will not have any problems. The students make mistake because they write it like this. And they think they solved the problem. Let me just warn you that this is not correct. Okay? Wrong. What is wrong with this? Anyone else? Yes, Ali?
This is a squaring pattern.
A squaring pattern. So I just square this one and I square this one. But 2 times the first one times the second one also should be. So what is the correct one? The correct one is this. So 2x plus 1, 2 times the first one times the second one, plus the second one squared is equal to 49. So this is the correct one if you write. It is not wrong, but immediately you see it is useless. Because how many square root signs I had? I had 1 square root signs with this equation. If I square it like that, still I have a square root sign left, but I hope that you agree this equation is even harder than the original equation. So I'm not making the problem simpler, I'm making the problem even harder. Yes, is that clear? So you see, this is totally wrong. So you're not allowed to use it. This one is correct. You are allowed to use it, but I wouldn't say that this is a good idea because this is the original problem. This is the new problem. Everyone, by looking at this, I immediately understand that this is easy. So I'm making problem hard. So even though it is correct, we will not go for it. So this, I need to think a little bit. Is there any way to avoid this or not? Yes, Sergey?
We move x to the other side
and then square it. These things you need to, so the hard problems become of this nature. So you need to find a way to organize them and then square them so that I can get rid of the square root signs as soon as possible. Yes, exactly. So here, it's extremely important to listen to this method. So you just write 2x plus 1. I move x to the other side, it becomes 7 minus x. I hope that you agree with me now that I solved the problem. Yes? Because now if I square it, I immediately get rid of that. So let me just be patient and write everything in detail. And then this one is squared, so it is 2x plus 1. On the other side, I get the squaring rule again, so it is 49 minus 2 times the first one times the second one, and then plus the second one squared. And I hope that you are happy now, because that is a reasonable, simple question, equation to solve, and without the square root signs. Yes? And then how should I solve that? For example, I move it, because I know that this is a quadratic equation at the end, so there is no point to move x's on one side, numbers on the other. You have to move everything to one side. And I always prefer to have x squared positive. I don't know. That is just my personal feeling about x squared. So I keep that one and I move the other ones the other side. So minus 14x, 2x to the right, it becomes negative 14x, sorry, negative 16x. And then 49, I move 1 to the other side, 48. Instead of putting 0 here, it doesn't matter if I put 0 there. Yes? And then I start solving this equation. And then I don't know, can you guess two numbers? If you can guess, factorization is the best way. If you cannot guess, in this case you can use PQ formula, is easier even. Or if you want ABC formula. Yes? Okay, now can you guess the numbers? I need two numbers. If I can guess, I always try to think about it. Can I guess two numbers whose sum is this and the product is this? I think in this case it is possible. Sometimes it is not possible because there are not friendly numbers. If they are not friendly numbers, I cannot guess. Yes?
4 and 12.
4 and 12, yes. But which signs?
Minus 4.
Minus. Agree? Because minus 4 minus 12 is minus 16. Minus 4 times minus 12 is positive 48. Yes, that's correct. And then I put it 0. Then how many answers I get? 4 or what? 12. But if I ask you, are these numbers solution to the original equation? No. You see, the process of solving starts for this equation, which is not the original equation. But what I know is that the solutions of this equation are among these solutions. But there is no guarantee that these are solutions unless I check them into the original. And that is part of the problem. So if you don't do that, you will lose some points for this question. Yes? So if I want to check, I check it in this way. I come here, I will write the left-hand side. I want to check x equals to 4 first. Left-hand side is equal to square root. Instead of x, I put 4 plus 1. And then I put 4 equals to 7. Oh, sorry, not equal to 7. I continue to see if it is 7 or not. 2 times 4 is 8, plus 1, plus 4. This is the square root of 9 plus 4. This is 3 plus 4, this is 7. It's right. So this is the right hand side. So is this answer acceptable for this original equation? Yes. So it's not a false root. Yes? And then I check for 12. So x equals to 12. The left hand side is equal to square root of 2 times 12 plus 1 plus 12. I replaced x everywhere with this answer. So how should I calculate this? You see that this is not working. 2 times 20, this is 24 plus 1, 25 plus 12. Square root of 25 is 5 plus 12 is 17, and 17 is not equal to the right hand side. So that is the false root, yes? So that is a very, very nice example. It was very simple, but it contains all the points. One point is that do not start naively by squaring. Try to think a little bit and organize your equation in a way that when you square, you get rid. I will come to you. And then when you get the answer for the equation without the surd sign, it doesn't mean necessarily that these solutions are accepted. Yes?
When we answer the question, do we have to write x is equal to 4 and that x equals to 12 is a false root, or are we supposed to write just that x is equal to 4?
No, I think it is better for this example, this part, you have to write more or less like this. So, and that is also part of the solution to this problem. So that's exactly what I have written here is the solution. So these also should be included in the solution. Yes, thank you for this question. Okay, any questions here? Okay, so if you don't mind, let me just try to show this in GeoGebra. For example, if I want to, let us see if it works or not. You just need to be patient a little bit. Okay, so if you remember, I don't know if GeoGebra, I think GeoGebra also solves this question. So let me first test that idea. So you go to CAS view and try to solve your equation. Yes, so solve equation in X. Yes, I take this one. And then I will start typing this equation. So what is the equation? It was square root of it was 2x plus 1, and I go out, plus x equals to 7, and if you solve it, you see GeoGebra knows that there is only one answer to this, and that is x equals to 4, which is the acceptable one. Okay, if I go back to this original view, so I take this one and I go to algebra, okay, and now if I want to understand it from graphical point of view, how should I, this is important to understand this question. From graphical point of view, how I understand this problem. Of course, drawing the graph of these surd signs is hard for you, and I don't expect you to do that. Assume that I give you the tools in GeoGebra, and you want to analyze the problem graphically. So what you do? Yes?
Write the equation on the equation.
So for example, you say that I write a function y equals to, I can type the...
You don't have to, you can just type the equation for... No,
graphically.
no, wait, no, never
So I
mind.
need graphically means that I have two functions. I want to find the intersection between those two functions. Yes?
Oh yeah.
So here I can do like this. I can type this exactly into this. So this one is 2x plus 1. Then I have a plus x here. So that is the graph of this function. Yes? I don't know why. So show grids. Okay. I don't know. Could you anticipate the graph would be like this somehow? might be you cannot understand the behavior of the function, but you should be able to anticipate that will not go to the left that much. Why? You see, this number is minus 0.5, and 2x plus 1 becomes negative if x becomes less than minus 0.5, and this function is not defined. So it was predictable for you that there should not be any graphs on the left hand side of minus 0.5. Yes? Okay, and then on the right hand side I have the constant function 7. So I write y equals to 7. And I draw that one as well. So I have to go higher to see that you can see this. This is the other function. So on the other side, on the left hand side, I have this function. On the right hand side, I have 7. I draw both of them, and I see I have only one intersection point. And you go here, for example, you take intersection of that and intersection of this. This gives you A, and you see the x coordinate of point A is exactly 4, and 4 was the answer to this problem. Is that clear? This is one way to do it. Yes? But for example, you could take this function. Let me just clean these two. So let me type it for the time being. So square root of 2x plus 1. And then I have this one. Let me just draw this one. I get rid of these things, not to distract you. Yes. So this red one is the graph of only this part. Let me imagine in my head that I have moved x to the right hand side. Then I will generate 7 minus x. So I can draw the graph of y equals to 7 minus x. This becomes this graph. Yes. And now I go to intersection again, and I find the intersection between these two. But again, the coordinate, x coordinate is 4. So it doesn't matter how you interpret that, you can answer the questions graphically. So the only thing that you don't understand here, why this red curve is the graph of this function. You will try to learn these things in Math 3C. After we learned about derivatives and how the function behaves, yes? But graphically, if you have access to GeoGebra, you can more or less solve all sorts of questions by asking GeoGebra to draw them and to see how many solutions are there by finding the intersection points. Is that clear? Okay, so I don't want to spend more time on GeoGebra thing here because I want to go back and solve some harder problems for you to increase your skills in solving this kind of problems. Okay. So the question in the book is square root of 6x plus 1, and then I have minus square root of 2x plus 1 plus 2 equals to 0. Okay, so I want to hear from you. I want to solve this equation. It's a third equation, or a root equation, but it contains even more square root signs here. Okay, how do you think we should solve the problem? This problem I consider an A-level question because by one step you are not able to solve it. So you have to be patient and you have to be careful about your algebraic calculations. So what is your suggestion to solve this problem? Yes?
I would personally probably start by making 2 to square root of 4. Is that?
So may you repeat again? I didn't understand. What to do?
2. I would make 2 to square root of 4.
Okay, then how it will help?
Well, I want to combine it into the other one.
No, you cannot. Be careful about that. It's very important. So you are not allowed to write something like this to combine them. Please write this once for all. If you want, I can swear it's not right. Yes. So you need to learn it once for all. These kind of calculations are not correct. But this one, probably you're always confusing this with that one. Yes. In this case, of course, if A and B are non-negative, then this is true. But this will not work for. This also work for division. If of course they are positive. But this will not work for positive or negative signs. Okay, so this is not working. Okay, then, because it was very, very simple if it worked, yes? Then I could combine these two and then move one of them to the other side and I am done. But this is unfortunately not working. Yes?
At least we can make it a bit easier by moving a third sign and the two to the other side. Or only one of them.
Yes, exactly. So, and I really liked your phrase. You can say, at least we can do better. Yes, that's exactly the way that I was thinking. So if you don't mind, let us move this one to the other side. It doesn't matter. You can say that I can move these two to the other side. But the situation is the same. There would be a square root sign, a 2 left here. I move this one, it becomes alone. Or if you want, I can move these two to the right, and then this becomes alone, but the right-hand side becomes the same situation, yes? So what I will do, as you said, I move this to the other side. Okay, then what? Yes?
Should be squared and
Then we have to square. At least, when I square, I get rid of one of them. Yes? Of course, I will not be able to get rid of this one immediately because that would be a squaring pattern. Don't get confused. So let me write the details here. So what you need to say, you say that if these two numbers are equal, then this to the power of 2 should be equal to this to the power of 2 as well. Yes? Okay, but the right-hand side, I am relieved. Because it becomes just 2x plus 1 without any surd signs. But am I relieved here? No. Because this is not just this 1 to power 2 plus this 1 to power 2. If it were, yes. But now I have to write the first 1 to power 2. Let us do it in my head. This 1 to power 2 becomes 6x plus 1. This 1 to power 2 is 4. But this middle term, you have enough experience now. It becomes 2 times the first one times the second one. So 2 times this times that, it becomes 4 square root of 6x plus 1. Okay, now let me ask you one question. Do you consider this problem easier than the original problem? I would say yes, because in the original problem I had 2 surd signs, but in this equation I have only 1 surd sign. So at least that's a progress. Yes? And of course you can do it even better, because there are many things that you can simplify right now. For example, I can write 6x, 1 plus 4 becomes 5, and then I have 4 square root of 6x plus 1, and then I have 2x plus 1. Okay. Now what is your suggestion? I think this is more or less obvious now. Should I square it immediately right now? No points, yes?
make the square root alone.
Make this one alone. So I move these to the right. So this becomes 4 square root of 6x plus 1. Let us do it in our head. 2x is there. I move 6x to the other side, minus 6x, 2x minus 4x. I move 5 to the other side, becomes what? Minus 5 plus 1 minus 4. And I think you are now relieved, because you know that one more squaring will solve my problem, yes? Because if I square it, I will definitely get rid of the last square root sign. But technically, I will not do that right now, because I can see that I can simplify a little bit more. I definitely simplify and then continue, rather than continuing and then being in trouble. So is there any way that I can simplify this a little bit more? Yes, Asar?
Divide both sides by 4.
4, yes, and I get rid of 4. So this becomes square root of 6 plus 1. This becomes negative x, negative 1. And what I have to do now is to square both sides. And then I hope that you agree with me that the problem is solved, actually. Because that one is the last square root sign left, and I'm getting rid of it. So here, I square it, it becomes 6x plus 1. And then this one, we can do it like this. This is, let me write it for you this time. You don't need to write these details in the exam for me. I really appreciate if you can do things quickly. So you really don't need to write these steps. But when I square it, it becomes 6x plus 1. What happens for the right-hand side? The first one squared is positive x squared. 2 times the first one times the second one, both of them are negative. When I multiply, it becomes positive. And then it's 1 to the power 2. Agree? Okay? So this is a quadratic equation. So it is not that I move x's on the one side, the others on the other side. But the good point is that if I move one to the other side, this one will cancel that one because it becomes negative 1. And if I move 6x to the left, x squared is there. 2x minus 6x is minus 4x. 0 is left here, but I prefer to put 0 there. Okay? What is your suggestion to solve this problem now? It's a very extremely simple problem. What should I do? Of course, I can always use PQ and ABC formula when I have a quadratic equation, but that is one of those cases that I can solve easily because C is 0. And when C is 0, the constant term is 0, the best way is to factor x out, yes? And then you can say that either x is 0 or x is 4. By the way, you can also use this trick, yes? I can say that I need two numbers whose sum is minus 4 and the product is 0, yes? So, of course, one of the numbers is 0, the other one is minus 4, yes? That's also possible. But anyway, before putting this in a box to admit them, to accept them, you have to check. But check where? Not in any one of these equations. Of course, you can always check before that you have squared. It doesn't matter if you check it here or here, but you are not allowed to check it here. Yes, be careful. So it doesn't matter. I would prefer to check it against the original equation. So then you write something like this. x0, left-hand side is equal to, instead of x, I put 0, 6 times 0 plus 1, minus square root of 2 times 0 plus 1, and then plus 2 is equal to, let us calculate. This becomes 6, 0 plus 1, square root of 1 is 1. This becomes 1 minus 1. Plus 2 is 2. But I am supposed to have the right-hand side 0. It's not acceptable. So it is not equal to the right-hand side. So x equals to 0 is a false root. Yes? And then I also check x equals to 4. So what is that? The left-hand side is equal to square root. Instead of x, I put 4. And to see what happens. 6 times 4, 24 plus 1, 25. Square root of 25 is 5. 2 times 4, 8. 9 minus 3. And then I have plus 2. So how is that possible? None of them are acceptable. So this is 2 plus 2, 4. Am I right? Did I make any mistakes? Let me see. The answer is in the book. Okay. That's correct. So none of them are solutions, yes? So you see that x equals to 4 is also a false root. And then if you want to answer this question, what do you say? There are no solutions. So it was not possible to guess something like that. It was not possible to guess that there are no answers for x so that this becomes 0. Yes. Okay, let me ask something for understanding. If I draw this with GeoGebra as a function, okay, what do you predict for the function? You can say something now, that this function will not intersect the x-axis. Because if you have a function that intersects the x-axis, these are the roots. Yes? And we learned that if I take this as a function, y equals to this, and I draw it, if it intersects the x-axis, there should be some roots for this equation. Yes? But there are no roots for this equation, so if you draw the graph of this function using GeoGebra, this graph should be either always above the x-axis or always below the x-axis. Okay? And of course, it is not hard to realize which one is which. For example, you can put 0 here. This becomes 1, this becomes 1. They are cancelled, it becomes 2. So it means that at 0, it is at the height 2. So it should be always above. Because if some part of it is above, if some part of it is going to be below, then I should intersect the x-axis. But I'm not allowed to intersect the x-axis. So it means that the whole graph of this function should lie above the x-axis. So that is the analysis that you can make. Any questions here? No? Yes?
Oh no, sorry.
So I think this is it. So I want to update the Google Classroom so that you can start working. You have to practice. I don't think you get a harder question. Yeah, you might have some higher level questions. If you don't mind, let me just solve one of them for you here, okay? I mean, I will give you time to do it yourself and then I solve it for you. So the question in the book is this question. It's a good question, I think. It is problem 3085, part C. So you are supposed to solve this equation. Square root of x squared minus x minus 10, and then minus square root of x squared minus 11x equals to 10. Okay? So I give you, I don't know, 5 minutes, 10 minutes, see how it goes, that you solve it. I think that's a hard problem in the book, so I want to wait for you to see how you can solve that one. Let me double check that I have written everything right. X squared minus x minus 10, that's right? Yeah. So I want to wait for you so that you can solve this problem. If you really can solve this problem, you don't have any problems with this section at all. Could anyone solve the problem?
Not yet.
Okay, I will wait more. Okay, before finishing today's lesson, I want to see, is it complicated? Yes? It seems so. I don't know why the book, I double checked, I didn't write anything wrong there. So let us see how it works. At least you can tell me how did you start, yes?
I have the answer.
You have the answers?
Yeah.
Good. So was it complicated?
It was lengthy.
Okay. So let us see, might be there is an algebraic identity you need to know that you haven't studied, then you have to multiply. Might be that's the case. Let us do that. Okay, what is your suggestion for me?
Well, first I isolated the first third sign on the left side.
To the right side, yes?
No, I took the second one to the right side.
To the right side, yes. I move this to the right side, so it becomes positive, yes? Because there is no hope if I want to square right like that. Why is that? I get rid of this one, but the 2 times the first one times the second one will give me a very horrible square root sign, yes? So this is motivating to move this one to the other side first. This becomes 10 plus square root of x squared minus 11x. That's the first step. The second step is probably clear, to square both sides, yes? So squaring this one, if you don't mind, let us do it in our head. If I square this, I get rid of this square root sign. But, let me just write it again. You don't need to write these details if you can do things faster. Okay, and then what I am supposed to do, so let me go down. I have to use the squaring rule to write something for the right-hand side now. So how should I write that? So I copy and paste the first part is equal to, when I square it, it becomes the first one squared 2 times the first one times the second one. And the second one squared, which becomes x squared minus 11x. Right? Okay, now, no, it is not that complicated, because now this x squared actually cancels this squared. If it was there, then it would be a little bit more complicated. Okay, so, but you have to reorganize things again. Okay? So you need to keep one square root sign on one side and move the other ones to the other side. When you square it, you get rid of the last square root sign. So if you don't mind, let me just do it patiently. So x squared minus x minus 10 is already there. I move 100, becomes minus 100. I move x squared, it becomes negative x squared. I move the other one, it becomes 11x. And what is left for me? Only this term is left for me on the right-hand side. Simplify it as much as we can. This and that are gone. 11x minus x is 10x. Minus 1, minus 10 minus 100 minus 110. Yes, am I right? And then on the right-hand side we have 20 square roots of x squared minus 11x. So what is your suggestion for me now?
Divide everything
By
by 10.
10. If you want to square it, it becomes horrible, but if you divide everything by 10, it becomes x minus 11. That becomes 2 square root of x squared minus 11x. And then hopefully you can guess what to do. I need to raise it to power 2 once more. So let me just do it patiently this time. This to the power of 2, it becomes 2 square root of x squared minus 11x to the power of 2. So that was a lengthy problem. But I don't say this is hard. If you just think a little bit wisely, you could find easily what to do. Okay, so what I have to do now, the left-hand side is again a squaring rule. So it becomes the first one squared, x squared, 2 times the first one times the second one, which is minus 22x. And the second one squared, 11 to power 2 is 121. But what can I write for the first right-hand side? I want to square this. I want to make sure that you understand. So what should I write? Yes, Absh?
4 times x squared minus.
Exactly, because this is a product. When I square it, there is no squaring rule. It becomes the first one squared times the second one squared. Yes? So that becomes 4 times x squared minus 11x. So what I do, this becomes x squared minus 22x plus 121. I multiply 4 in, so it becomes 4x squared minus 44x. I move everything to the right because I told you I want to keep the sign of the x squared positive. So I can do it in my head. So if I move it, it becomes 3x squared. I move this, it becomes positive 22. But there is a negative 44, so it becomes again negative 22. And 121 move to the other side, minus 121. Instead of putting 0 here, I put 0 there. This is one of those questions that definitely ABC formula is better. I cannot guess how to factorize it because the numbers are big. And PQ formula is not very good because you have to divide by 3 and work with fractions. So if you don't mind, let us work with ABC formula. So what is delta in this case? B squared minus 4AC. So it is minus 22 to the power of 2 minus 4 times 3 times 121. If you can help me with that, that would be great. So this becomes 484. Yes? And then how much is this one? Can you calculate this?
That's 1,452.
1,000?
452.
In that case, I have problems. So might be I made a mistake here.
No, you didn't.
Okay, sorry. This is negative 120. This is negative 121. So negative times negative is positive. Can you repeat the number?
1,452.
452. And if I add these two numbers, it becomes 6, 3, 9, 1. Yes? And that is positive. So this is positive. So it means that there are two roots. So one of the roots is, I would write minus b plus or minus the square root of delta divided by 2a. Minus b becomes 22 plus or minus, by the way, you calculate the square root of this. What?
44.
44, it's very nice. 44 divided by 2 times a, which is 6. So I will have two options. X is 22 plus 44 is 66 divided by 6 is 11. 22 minus 44 is minus 22 divided by 6, which is minus 11 over what? 3. Then I have real problems, yes? The reason is that I have to go back to the original equation and check those numbers. That is what we have to do. It's very hard. Not for this one, but this is hard for that one. Yes? So you have to work with it. Unless you can convince yourself somehow that is not possible. Okay, so let me clean this part of the board now. So it was a very lengthy problem. So for 11, I don't know how much, yes, we have some time. So, okay, we can do it patiently now. So if I go to the original equation, I have to replace every appearance of x with 11 to see if it works. Okay? So what should I do? For x equals to 11, let me double check this. I put the left hand side is equal to square root of 11 to power 2 minus 11 minus 10. And then minus the square root of 11 to power 2 minus 11 times 11 is equal to, let us see how it works. This is simple, this is 0. 11 to power 2, 11 to power 2 is 0. Yes? But this one, 11 to power 2 is 121 minus 11, so it is 100. And it is equal to 10. So, and that is equal to the right hand side. So that is not a false root, that is indeed a root. So x equals to 11 is acceptable. Yes? But what about the other one? That is really...
It was undefined.
Is it?
Yeah,
If you are lucky and one of the integrals becomes undefined, then we are good, yes?
yeah, I calculated the second one in GeoGebra and it didn't.
No, in GeoGebra, yes, but if you don't have access to GeoGebra, if you want...
Okay.
So let us check, I hope that this becomes negative, yes? So you see that if x minus 11, if I factor it in my head, and this number here, you see, is negative, yes? No, unfortunately it doesn't work, because this becomes negative, that also becomes negative, and this becomes positive at the end. But if I do this one here, let us see.
No, it becomes negative.
It becomes negative, yes? So this you don't need to really, by the way, this is important. If you want to calculate the exact value, that would be horrible. Yes, you have to put these that very nasty number here and see that it works. But let us be a little bit smarter. So what I do, I factor this out. I just want to convince myself with the hope that this number turns out to be a negative number. Because if this number turns out to be a negative number, it cannot be under the square root sign, so it means that that is not acceptable. And then hopefully you immediately convince yourself that is indeed the case. Do you agree with me or not? Not easily, but we have to check. So this is x times x minus 1 minus 10. And the x that I am checking is minus 11 over 3. Let us see. If I put minus 11 over 3 here, minus 11 over 3, minus 1, minus 10. This is not hard to calculate. So this, it becomes minus 14 over 3. This becomes minus 11 over 3, multiplied and minus 10. Yes? What is this number? This number is positive. 11 times that is 145 minus 10. Unfortunately, that's also positive. So you said that it's negative?
No, I made a mistake. I thought it was negative.
Yeah, that is positive. Then that is horrible, yes. So if I calculate this, it is 90 and then it becomes 64 over 9. We have to work with it. So sorry, there is no shortcut. So we have to check it. Okay, so x equals to negative 11 over 3. So left hand side is equal to, I calculated that, if you don't mind, I put the numbers here. I got 64 over 9. Yes? And I have to calculate the second one as usual. So, but usually factoring is easier for me. So if you don't mind, let me just use factorization. So this is minus 11 over 3, minus 11 over 3, minus 11. Yes? So if you are patient, I can take these minus signs away. Yes? And then 11 factored out, this is 121. And then this goes 4, and then divided by 9. Yes? So that would be the number. And then I have, so let me calculate. So then it becomes 8 over 3. This becomes 11 times 2, 22 over 3. And then you get, it is minus 14 over 3, which is not equal to 10. Anyway, so that number is not acceptable. So I did it a little bit quickly, but that is just normal calculation. You put your number and calculate it. Did you get the same answer? Minus 14 over 3?
Yes.
Okay,
Yeah,
good.
I mean,
Okay, so that becomes a false root. So you go back here and say that this is acceptable. It's a false root. And then, okay, so that's the end of this problem. So I would say that if you can solve this problem on your own, you don't really need to bother anything about this section. Any questions? Okay, so you see that I did it a little bit fast. I did it in my own way. You really don't need to worry about that. What you need to do is to take minus 11 over 3 and patiently put it here and calculate. At the end, if you have done the calculations right, you should get it minus 14 over 3, which is not equal to 10, so that's a false root. Okay, thank you very much. We'll stop here.